So, good morning. Welcome to day 6 of writing a TCP IP chat application using just plain old socket, plus a few other things. We have pipelines and channels at this point. But the idea is just a raw TCP IP application. This is day 6. Probably still have a few days to go, honestly. So shout out to my GitHub sponsors. You're awesome. And if anyone has any questions live, you can drop them in the chat. If you have questions, after the fact, you can reach out to me on Twitter, @SteveCleary, or you can just post a question on Stack Overflow. There are tons of people who can answer on Stack Overflow. So let's switch over to my screen. I just want to walk through real quickly what we have here at this point. So we have this PipelineSocket, which takes our regular socket, just a socket class, which is a stream of bytes abstraction, and it wraps it into actually another stream of bytes abstraction using pipelines. And the reason we do that is to make the parsing easier for the messages. And then we have this ChatConnection type, which then wraps that and gives us, now we have this bidirectional stream of messages, or actually 2 unidirectional streams. So we've got incoming messages and we've got outgoing messages. And these each have their own queue, which is this channel here. So we've got, now this is like a stream of messages, right? That's our current level of abstraction. We're going to keep it at this for a little bit. I am planning to add one more layer of abstraction here before we actually consider this done. But today I want to take a look at what we currently have, and I want to look at error handling and also socket closure, because those two are kind of related. So first I want to talk about error handling, like in a general sense, when you're talking about sockets. So back to my frequently asked questions for sockets on .NET, which I wrote, I don't know, 13 years ago it says, 13 years ago. All right. A long time ago. So, and I never actually finished, because what we're going to be talking about a bit today is closing sockets. And I always meant to actually finish up this series, this FAQ with actual 1 or 2 posts on closing sockets, because that can get a little bit complex. You have a few different options and stuff. But I'm just going to talk about that off the top of my head today. I never got around to writing those blog posts. So this series is actually unfinished. Like, probably half the series on my blog are actually unfinished. So let's look at error handling. And this is still the same way as it was 13 years ago. So essentially what it comes down to is when you get an error on a read or write operation on a socket, that socket is done. Okay, you can't recover from that. There's no way to say, well, I want to still use this socket for something else. I know I got an error on a read, but I want to write to this. I want to write one more message to the socket. Well, that just doesn't work. Once a socket has an error, then it has an error. And this is an error, not a close. But the socket as a whole enters this error state. So essentially the only thing we can really do in a response to an error is to close the socket. So we should be immediately closed when any of the read or write or disconnect operations error out. Disconnect we don't really need to worry about. But essentially, we're just going to close this socket. If there's an error, we want to close the socket. And then I talk about some of the more common errors that you'll see. We don't really need to get into that today. I do talk about retries in here, which I'm actually not planning to cover in this series. In a real-world application, say if you have a client socket and you're talking to some server socket in an embedded device, if you have an error, what you want to do is wait some time and try again, right? If you have a connection error, well, you just wait some time and try again. I'm not going to be doing that as part of this series. That gets more complicated with the, you've got that additional layer of timers. It's like yet another layer to the application. So I'm just dealing with a simple connection here, and yeah, we'll talk about errors. So one of the things that I like doing is when you have an error coming from a socket, what I want to do is, best effort to latch the first error that comes in. So what I really want to report upstream is the first error that happens. I don't know, I think with sockets, once you have one error, then any future reader writes will also cause that same error. So I think the socket latches it for us, but I'm not actually 100% sure on that. So anyway, I always just latch my own errors. So let's take a look at what that looks like. So the only code currently in our quote-unquote layered architecture that talks to the socket type is this PipelineSocket. It exposes the socket for things like setting socket options and things like that. But this is the only one that actually does any reads or writes. And the other question is, how are we going to propagate this error, like upstream, so to speak? And I think that the best way to do that, since we have this read stream at each layer, at the PipelineSocket layer, it's like a pipeline, it's a stream of bytes, and at the ChatConnection layer, it's this stream of messages. We made this iMessage type that we're passing up iMessage objects. So I think that the best way probably to handle this is to report it through that stream. Okay, that's what I'm thinking. I'm kind of making this up as I go along because I've never written a TCP/IP application with pipelines and channels before. It's always just been, make up your own things. So I'm kind of making this up as I go along. But I think both pipelines and channels allow you to close or to complete the pipeline/channel, and they also have this ability to complete it with an exception. I'm pretty sure that's the case. So I'm going to try to make use of that. Hopefully that exists. So first off, we're going to look at our reading code, and if we get an exception from the socket, it's going to come in right here from this receive async, which is fine. What I really want to do is actually just wrap this whole thing in a try catch. So if this thing ever actually exits for any reason with an exception, any exception, then what I'm going to want to do is say PipeWriter dot complete. There's a complete async too. Not sure why we would need to do that. What's the difference exactly? I don't know. Okay. I'm trying to think of why. Would it actually wait for it to be read in that case? Odd. I don't see anything in the immediate IntelliSense. Let's jump over to MSDN docs for this. Just want to make sure I use the right thing here. So this is a PipeWriter complete async. Value task that represents the asynchronous complete operation. That's not terribly helpful. Okay, so let's jump into the source code. Nothing like diving into source code, right, when you're just trying to write an app. But all right, pipelines are still relatively new. Let's see, so we found the library that it's in. Now let's just jump to PipeWriter. Skip over the test ones, and here we go. This looks like what we're looking for right here. And, oh right, yep, I forgot. So PipeWriter is actually just an abstract class. So by default, CompleteAsync just calls complete, and that's it. So let's see, there's also like this default PipeWriter, which is what the PipeWriter actually is for the pipe type. All right, so let's see here. It says complete just calls CompleteWriter. Does it override CompleteAsync? It does not. Okay, so the default implementation does not do anything different. Does not actually behave asynchronously on a complete. So that's fine. We'll just call the synchronous implementation. Don't care. All right. So we're going to call complete with an exception. And, okay, so we already handle, if it closes, we call complete without an exception, and then return. Yeah, that's what we want. If it throws an exception, if the socket throws an exception, then we want to pass that along down the PipeWriter. Yes. Now, the trickier part is when we are writing from the pipe reader to the socket. This can also throw, the send async can also throw. And what we want to do is have a way to complete this PipeWriter. So here's the problem here. I'm not sure if this if we can call complete on a PipeWriter more than once. So what I'm going to do is I'm going to do my own little latch here. All right. So I'm just going to toss in a task completion source, and this is just, this will be our completion. And let's create a new one. I don't know if we even need this main task anymore, but I'm going to do that because what I'm actually doing is I'm using the PipeWriter as my main task. Or the pipeline, yeah, as my main task, which is, that may work. So let's start hooking this up and see how it looks. So now, instead of just calling complete, I want to say if my completion, if I can try set exception on that, then I can complete the pipeline, complete the writer. And then over here, what I want, if I'm reading from the pipe, I also want to complete this. And here's where it gets a little tricky. Because what we want to do is actually close that socket. Oh, I didn't actually close the socket. Right, duh. So you know what? I'm gonna extract this out and do like a separate close method. All right. Say it's actually going to be a try close, but I don't care if it completes or not, so I'm just going to say I'm going to keep the name as close with an optional exception, and this code down here is just going to get popped up in there. Going to try to complete it. Yeah, okay. Oh, and I do have my writer and reader here. So what we can do, what we want to do, I want to flow all errors up through the output, or sorry, the input pipe is where I want all errors to end up. So, all right. Well, first, let's say if there's an exception. No. I'm not sure where the disconnect there is. So I can tell since it's offering one thing and I hit tab and it does something else. I don't know. Anyway. So if we have an exception, then we try to set the exception. If we were the first one to complete this, so this is the first exception coming in, then I want to say, I do want to complete this input pipe, which would be input pipe.writer.complete with the exception. And then we also want to close the actual socket. Now, otherwise, if this wasn't the first exception, then we're not going to actually complete the input PipeWriter because it's already complete. And again, I'm not sure if it can handle multiple calls to complete. It might throw in that case. Let's just jump over to the docs and see if it says it'll throw. No, it doesn't say if it'll throw or not. Okay. So I'm going to allow it to throw. If it wants to throw, fine. I'll do the latching myself. All right. So otherwise, if it's not, or if there isn't an exception, then we want to try to complete this task completion source with a success. Try set result. We don't really care about the result. And if we're the first one in to do that, then we're going to do this. Complete the pipe without anything. Okay, I think that makes sense. So if we're reading from the socket and it closes, then we're going to pass along that closure to the input pipe. I think that'll work. Okay, so then we can just say, now instead of this, we would just say close. And down here, we would say, what is that? Right. And down here, we would say close and pass the exception. All right. So this handles all, I think that this would probably handle all errors on reading from the socket. Now, writing to the socket, if there's an error coming in, so we already handle, so this happens if we, so we're saying we can close the socket implicitly by completing our incoming pipeline, which is fine. I'm just going to replace this with the call to close. And then I'm going to want to also wrap this in a try catch. I'm just going to go ahead and do it right at the top level. If there's some kind of exception in here during any of this processing, then I want to close with the exception. And what that does then is if there's an exception on reading or writing to the socket, then we're going to close the socket and we're going to notify our upstream of the exception by completing our input pipeline with that exception. That's true on reads or writes. I think that makes sense. Okay. So now we're reporting our completion through this input pipeline. So we actually don't really need main task anymore. I'm thinking about just getting rid of this thing. Let's do that. Bye-bye. Okay. That looks good. Okay. So now I think that this pipeline socket is much more complete. Now it handles closing, it handles exceptions, error situations. Now our API has changed a little bit, so we need to update our next layer, the chat connection, with some of these new semantics. And the chat connection is also going to propagate any errors, but since it's just going to get it from the pipeline, and it's going to propagate it on its own input channel, I don't think it actually needs a main task either. Okay, let's see how well that works. I don't know. Oh, right. We still have to call these. I think I just took those out in this class. Yes, okay. So we still need these main loops. Let's not get rid of those. But what we can actually do here, now these discards are okay. These were originally discards, I think, from a couple days earlier in this code. So now these discards are all right, and the reason for that is because this pipeline to socket async, or each one will always complete eventually, and it has its own way of reporting completion and exceptions. Since we hooked these up to the pipeline now, that's how they're communicating their completion. So this, let's look at socket to pipeline async first, because that's the more straightforward one. So we do have like this infinite loop here. It's still like a main loop. It's a main task, so to speak. That's just copying data from the socket into the pipeline. If the socket ends, if we have this graceful close, then it closes the pipeline. It completes the pipeline. If there's any exception at all in this top level method, then it notifies the pipeline of that exception. So because we're channeling all of our completion and results, if there are any, there's not in this case. There's no results from a main task. But as long as we're getting like all of our completion, notification, our results, and our exceptions to somewhere else, then we have this situation where we can say, all right, we have this asynchronous method, and we can just discard it. Or we can even make this async void. This is a... So I tend to make them tasks with discards, but you could also just change this to async void. And actually that might be a little bit safer, because like just in case I have a bug in this code here, or something in this closing code throws and doesn't actually complete correctly, then the async void would pick up on that and crash the application, which is usually desirable if you're writing code talking TCP/IP. But I'm going to keep it just as an async task for now, I guess. Yeah. But anyway, yeah, you can discard with an async task, or you can just do async void. This is like the one place other than event handlers. Right? Sorry, a little tired. So async void is for event handlers normally, but when it comes to like this main loop kind of idea that crops up from time to time, if you have like this main loop and it's reporting all of its completion and errors and all of that, it's catching all of its exceptions. You got this top level try catch in it. In that case, this can be async void too. Okay, matter of opinion or preference. So I'm going to keep it as discards, but feel free to make these async void if you prefer. All right. Or you know what? Actually, I'm going to make them async void. Because that way, if there is a bug in this code, it'll actually crash the app. And I like that. So I'm going to make these async void. Now my top level main tasks are both async void. So yeah, so I walked through this one. Sorry, this one, same thing. It's got the infinite loop, but it has a natural close condition, and it reports that elsewhere. And then it also has a top level try catch for any exceptions, and those are also reported elsewhere outside of this method. So there's no need to actually await these, is the point. So here we go. Async void not being used as an event handler. Yeah, all right. So this is one of the more, like, I don't say advanced, but it is kind of advanced. One of the more advanced ideas in async and await, where, okay, async void should be avoided except you're using it for an event handler. Or there's also this idea of like this main task that properly handles all of its own exceptions and everything. Okay, so I'm good with that. We'll do that. And then, right, so now we have to go back up to the chat connection. We're going to get rid of this main task too. So the other option is to keep the main task around and actually have some way of like tying that into a like an unexpected error kind of thing, which might be a cleaner solution, but I'm just going to take it out for now. We'll see how it is. So let's see here. Now we want to walk down here. This is copying from, let's do the other one first. Pipeline to channel is reading the incoming messages from the pipeline, parsing them and putting them into the input channel. And right now we've got this, it just breaks. Okay, so we definitely want to, well, actually, let's write this this close type, or close method, just like we did with the other class. Let's see, we've got a private void close, and of course with an exception. I think channels can be closed with an exception. If not, this is going to be a short trip here. All right, if exception is not null, then we want to need a latch. Actually, I don't think we even need to latch on this side, because our next level down API reports all exceptions up through its incoming pipeline. I don't think you can get an exception right into the outgoing pipeline. You would wait, you could end up waiting. Have to look into that. Think about that one. Yeah, that's actually going to be a problem. But first things first. All right, so let's just propagate exceptions from our lower level. So if the exception is not null, then we want to take this is our input channel, .writer, we do have a complete. Oh, we even have a try complete. That's nice. Very nice. Try complete exception, and you can even, and it has, yeah, so we don't even need this if at all here, since it can be null. So we're going to try to complete our input channel with the exception. And is that it, actually? Yeah, we don't have anything lower level to close. Just thinking about our output channels and how those are related. So we've got so this is for the read mainly. If there is an exception, We'll just keep it at this for now. And when we're doing our reading here, this read async should result in an exception at the point that the socket hasn't any exception. So I'm just going to grab this thing. Oops. Grab this thing here. We're going to catch any exception, and we're just going to call close with that exception. And we also want to pass on completion here. Okay. So now our incoming channel is going to complete when the socket closes gracefully, or it's going to complete with an exception if the socket has any error. So this is good. There is one other thing that I want to look at when we're talking about error handling here, and that is, let's look at this output. So what we want to do is we also want to close down our writing at the same time. And this is where it can get a little tricky. Let me just pop back over to PipelineSocket and think about how this one would work. So when we have a receive, most of the time we're gonna get an error on a read. Okay, so most of our exceptions are gonna come in here. It's because we are reading continuously. It's also possible to get an exception on a write. And in that case, we also close. But the question is, so this incoming pipeline, or this output pipe, I should say. The wrong one. So the output pipe, the one that we're using to write with, is not actually closed. It's not completed. And my concern is if something is still trying to write to that pipeline, trying to flush it, and the pipeline's full, and we get an exception on the read, we need some way to inform that writer that you're never going to complete. So specifically, this code over here that serializes this chat message and then writes it out to the pipeline, to the output pipeline. That's all fine. This part right here, this await flush async. So this, and here's where I'm not as clear on pipelines. Will this be canceled? No, it can't be. It can't be, because these are independent pipelines, right? We patterned it just after, the same way as sockets work. You have two unidirectional streams. And with sockets, the socket as a whole goes into an error state. So your input and output streams become in an error state. And what I want to do is replicate that same idea at our next layer up. So our pipelines, we have two independent pipelines. And right now, our input pipeline is the one getting all of the error notifications. So I wonder what would happen if I called complete on a pipeline when something else was already waiting for the flush async. And the answer is, I have no idea. I'm not that familiar with pipelines. So I don't know if, let's see if Google knows. System IO pipelines. If I call flush async and then I call complete, what happens? Actually, let's just see here. That doesn't tell me anything. All right. That's talking about flushing. Okay. I don't know if anybody has actually, well, it's not documented. So let's just say that let's say that so I'm not going to depend on it because it's not actually documented. So what I want to do is actually cancel this flush in the case that an exception comes in, which is doable. What we can do here is have our own little where it's too early in the morning. What's it called? The cancellation source? Cancellation token source. There we go. Way too early. Right. This will be our completion. Our completion notification. We'll just new that up there. And then, where are we at? Close. When we close, we try to complete it, and then we can call completion.cancel. And in this case, like I could say, if try complete, was successful, then cancel it. But I know the cancellation token source, you can call cancel multiple times. It's fine, I think. Yeah, so let's dispose. All right. So now our writer, yes, so writing to the output, from the output channel to the output pipeline, I want to make this cancelable. I'm just going to pass that in there. And then actually, you know what? I did see something interesting in that Google search here for this. Because it looks like there's, in this flash result, there's an is canceled, or they could throw an operation cancel exception. I'm just looking to see which one it'll actually do. Okay. So there's a flush result.is canceled. Okay, here we go. Here's how it works. The flush results.is canceled, someone called PipeWriter.cancel pending flush. Interesting. Okay. It does throw operation canceled exception if we use the cancellation token. So I didn't notice that there was a cancel pending flush. That's interesting. So maybe that's all we need here, is to say, instead of this completion cancel, we can say PipelineSocket output socket output pipe dot cancel. Oh. If I can spell it would work. Come on. Cancel pending flush. If there's no pending operation, this cancels the next operation. Interesting. Okay. Yeah. So what we actually want to do is close it. I think we actually want to complete it, actually. So can we complete our... actually complete the output pipe? Or what we can do here, let's do the cancel pending flush. I think it's probably the best option, and then we'll detect that down here and break out of our loop. So that way we're not going to try to flush again. So probably can't see that. There we go. So let's pull out this flush result, and if we were canceled, then we're going to break out of our loop. That would work. Okay. We do have this exception happening here. Okay. Well, we'll deal with that in a minute. Okay, so let's walk through this here. So now we don't actually need our cancellation token source anymore. I keep thinking I want to just put a latch in here too, because that would just make things easier. Well, it would make some things easier. All right, so let's walk through this, see how we like it. So in our chat connection now, when we have an exception in our reading, our input pipe, so we detect that, we pass it up. That's exactly what we want. When we have, we can have an exception in our writing still because of this invalid operation exception, and that's the main thing that I'm concerned with here. But any exceptions in our reading will also now cancel any writing and prevent any more bytes from being written out to the pipeline, which is exactly what we want. We actually call this complete then in that case, which is fine. Okay, so what I'm thinking is, I'm just gonna also wrap this in an exception, or try catch, and I'm also going to just call close exception. And really, this one should become part of our close too. So this over here should just be yeah, okay. So this one here should just be close. And we're gonna move this up to our close. Going to cancel any pending flushes, which will cause this loop to exit if it hasn't already. And then we're also going to call complete on that. I think that'll work. All right, let's see here. I just want to check one other thing in our PipelineSocket. When we are writing pipeline to socket, result that is completed then close. Okay, yeah, that's what we want. So what we end up here with our API now is we have the ability for the socket to report any exceptions up to us. We also have the ability to close a socket actually just by completing our output channel. Now, what happens if we complete the output channel with an exception? I gotta walk through this one because I'm not sure if that really makes sense. So it would come in here, try catch, we'd close with this exception, which then tells, so we would close our input channel with that exception, or complete it. Our output pipe on the pipeline socket we would mark as complete. I think that makes sense. Because what this would actually happen is, or the way that this would happen, is then if somebody completed our output channel with an exception, then that would actually flow to our input channel and be reported as an exception back to them. But in the meantime, we would actually gracefully close the socket because there's no way to really close the socket with an exception. So I think that makes perfect sense. That works. All right, I'm satisfied with this. Let's oh, and we've got once again we have our top level methods that are reporting closing and exceptional situations elsewhere. So I'm going to make these async void. Might come back and put that main task back in, just because sometimes it's useful to, like, so this is fine if you're running an application and this is like the main application is your TCP application or your TCP IP app. If you're like hosted in something else, you might not want to take down your entire host if there is a bug in your code, which is what these async void methods will do. With a main task, you would end up with like just an exception on your main task. The problem is, if that's not handled, if nothing awaits your main task, well then you don't actually properly respond to those. Yeah, so I'm going to keep it as is for now with the async voids, but I might readdress that. Okay, so we've got this stream of messages now. We've got the so the idea is we can send a message. Oh, we don't actually have a way to mark this as done. So let's go ahead and add that actually, since we've got this. Complete. Mark is complete. And I'm not going to offer to pass an exception here. So this will be the output channel .writer.complete. Yes. So this marks it as complete. We can send the message, which, yeah, could throw if it's already been marked as complete. So something to keep in mind, because we're about to get into the place where we have an entire list of server sockets and things like that. Or like on the server, I mean, we'll have a list of client connections. Okay, so I think this looks good. Let's see if we build, if we're using those main tasks somewhere else. We are. Okay. Let me just jump over here. So to do, I have a discard. All right. So this is the scenario here where we have that main task, and we would actually have to have something awaiting that and listening to any exceptions if there was a main task. Since we took out that main task, we essentially replaced it with async void. We don't need this. That also means that our input messages here are going to, they can complete with an error. So let's just wrap this all up in a try. And I'm just going to say, I'm just going to write this out for now. Type in there too. All right, that should do that. So now we can report any exceptions there. We should really be doing the same thing on our client side. On our client side, we're not reading yet. That's why there's no error handling over here. We're not actually reading from the socket. So this is an error in usage right now. Eventually, we're going to need a loop like this and a wait for each on the input messages for the client socket as well. Right now, the client socket is just writing. All right, so that looks good. Let's build this thing and let's pop over here and see if we can get it working. Alrighty. Let's run our chat server. It is listening. We can run our client right in the debugger. Oops. And I can say connect, and it'll connect. All right. I can send one message. I can send another message. And I can also, I want to terminate this process without giving it a chance to close down the socket correctly, and I don't know if this will actually work. Let's see. I'm just going to stop it. Yes, perfect. Okay. So now we got an exception surfaced all the way up from the socket read up to the pipeline. That exception got passed into the channel, and which got passed out of that await for each into our server loop. And we got that exception message saying an existing connection was forcibly closed by the remote host. That's because I killed that process. Well, actually, it's for two reasons. So first off, I killed that process. Well, no, actually, that would work even remotely. I was going to say it's only a localhost thing, but I think that would work remotely also for, boy, I don't know. Because normally what you would see is on the next write, you would see that error. But in this case, it happened immediately. And I think that's because it's on a localhost. So localhost has some shortcuts that it takes that you need to be aware of when you're doing TCP/IP applications. Because a lot of the times you can do something like this and say, oh, see, I saw that exception right away. That worked because we're running on localhost. You would not normally see that exception right away if this was on a remote host and it was killed. I'm not sure if the operating system would send out a reset packet. So what's actually happening here is the socket is getting a reset packet from the OS, and there are when you're dealing with localhost, Microsoft Windows will kind of it'll give you some extra help when you're on localhost that you don't get when you go remote. And the problem is that can be confusing because if you're developing with what you observe and you observe the extra help coming from localhost and then you go remote and there's no more extra help, then that can be a problem. So what I'm saying, sorry, I'm kind of getting twisted around here. So what I'm saying, to put it as simply as I can here, that reset packet you're not guaranteed to get, not until you send. So even in the case of, so in the case of like a remote host where the entire operating system, say, loses power and just dies, it can't send a reset packet, right? It's not possible at that point until that machine comes back up. So you wouldn't get this, you're not guaranteed to get this exception right away, is what it comes down to. It worked now because I'm on localhost, but you're not guaranteed to see that closure right away. So let's just do, because what I don't have here is a message for when it disconnects. All right. So we got a connection, and I'm just going to add a message here saying, I don't know if lost connection is correct, but I would say connection at, I don't want to make it sound like it was, a mistake. That remote endpoint was disconnected. All right. So just to also include that message, now when I run my server here and it's listening, I can run my client. Now I can connect, and it'll connect. Now if I just exit this like normally, not kill it in the debugger, we should get a nice graceful close message. No, we did not. Okay, so that's interesting. Existing connection was forcibly closed by the remote host. Oh, right, because we're not actually closing it. All right. So we've got this connection here. I just want to get the graceful close here working. We've got this connection, and what I want to do is like on a close. Let's jump in here. Let's say so just when the window closes. Let's see here. I don't actually know. I think that's no, okay. Closing. Oh, closed would work. There we go. All right, so let's jump to this now. I want to say, if this is not null, then I want to essentially, oh right, it's because we have the send message and we just added the close here. Or complete. Complete is what we call it, yes. All right. So that would complete our socket, and then we would have the gradual close there after any existing messages were already sent out. So let's try that. Hopefully it works. Okay, so that server's still running. We'll just run the chat client and connect to the same server, and then when we close, did not work. It might be closing too quickly. I'm just going to add a close button. That way we can really, ensure that would work more properly. So, copy and paste here. This will be my disconnect button. There. Oops, that's not what I wanted. All right. And we're just going to do this. Alrighty. So now we have a connect and a disconnect button. So if I connect here, if I disconnect, so we're still getting an exception. So that's interesting. That it was forcibly closed by the remote host. So, well, let's walk through this. If we are, this is not what I expect. Yeah, interesting. All right, so we're completing this output channel. The output channel .writer.complete, which means that this one, the channel to pipeline, which is reading from the output channel, will exit this for each, and it'll come down here and call close, which then calls try complete on our input channel, which is interesting. Okay, I don't think that would cause this error though. And then it would essentially propagate the completion to the output pipe on the pipeline socket, which comes in here. We would get this read async result back. With an empty memory buffer, so that should break. And then it should call close with no exception, which will complete the input PipeWriter and then call socket.close. Well, that's interesting. I'm just going to walk through this real quickly, at least this part here. And just make sure that that is what is actually happening. So let's see. Connect. Okay. That was actually my breakpoint on the next line. Right. And then if I disconnect, then our result should be just an empty thing with, yeah, it's an empty buffer with is completed set to true. Yes. So we come in here, say, is it empty? Yes. All right. We advance the pipe reader, which didn't actually do anything. If it's completed, we close. So this is set now, and we complete our input PipeWriter, and then we call socket.close. And that's the interesting part. Like, why did it? Why is it getting an exception there? Interesting. So it's acting as though it's clamping the connection shut. Now normally with a socket, and this is why this behavior is odd to me. Normally with a socket, so let me explain a little bit about this, about how this exception works. Normally with a socket, there's a four-way handshake to close the socket. And that's like a graceful close. And last time I checked, the socket class, if you just call close, would perform a graceful close. The existing connection forcibly closed is a way to like clamp that connection shut faster. So it is actually used sometimes in like servers on the internet and things like that, where if you know that you're done with the socket, you can clamp it shut, as opposed to a graceful close. So that's odd though, that would be the default behavior for that, because I'm quite sure that didn't used to be that way. Let me see. There's an overload here. What's the overload for? With a timeout, which we don't really need, but it should have some listening. Yeah, we've got the listen, or sorry, not listen, we've got the linger state. Yeah, so the linger state should be set to should be set to true by default, I think. So this is odd, unless that changed. Let's see what it says about lingering. So it doesn't say what the default actually, oh, maybe it does. All right. To enable lingering, create a linger option and set the linger state to this instance. Interesting. So I thought lingering was, oh, here we go. Linger state false, the default value. Okay. I thought lingering was enabled by default. That is So this is how it's actually behaving here. It's behaving as though we have a linger state set to true with a 0 timeout. But that's not what it says the default is. Interesting. Okay. That's not applicable. All right. Okay. I'm just going to run this in the debugger again and just check to see if I can see what this linger state actually is on the disconnection. Let's jump in here and see what we got here. What's our linger state? Enabled is false, linger time is 0. Yeah. So enabled being false, that would be the default. Weird. Oh, silly me. I need to call shutdown. Yeah, this is something that I don't cover in my blog yet. Close is more of a close the handle, right? That's the problem that I'm having. Okay. So what I actually want to do is call shutdown. And so shutting down sockets. I'm going to talk just a little bit about this. Sockets are two mostly independent unidirectional streams of bytes. So you've got an outgoing stream and an incoming stream on each side. Or one stream going one way and one stream going another way, I guess is a way to think of it here. So when you shut down a socket, you have the option of saying that you only want to shut down one of those streams. So you can actually shut down like just your outgoing stream. And this was used in some protocols earlier in the internet, essentially. I don't know of anybody who uses it today, and I'm going to explain why in just a moment. But essentially, like if you think the first version of HTTP, right? HTTP 1.0, which I think was only around for a few months until 1.1 came out. But 1.1 allowed reusing the socket connection. 1.0 did not. So literally with 1.0, back in those days in the 90s, most web pages only needed one connection. You would make one connection to the web server and get the web page. Forget images. Most web pages didn't even have images, or style sheets weren't around. No JavaScript. No. So back then the web was much simpler, and you would just make one request and get the web page most of the time. So anyway, the first version of HTTP allowed you to make one HTTP request, and that was it. The result would be sent back, and the socket would be closed. You'd have to reestablish your three-way handshake, plus some more handshakes if you wanted SSL, and do that one request, the one response, and then do the four-way handshake close. So it's very inefficient. But anyway, when you have that kind of that kind of scenario where you have, I've sent my request and I know I'm not going to send another request, I can't reuse this socket, then I can go ahead and shut down my sending stream. And this actually starts that closing handshake, that four-way closing handshake. Okay, I'm closing my outgoing stream. And then the server can still send data on the client's incoming stream, the server's outgoing stream. And then the server can actually say, okay, I'm done with that. Here's my close, the end of my stream. So it is possible to shut down a stream going in one direction. And then the other side can actually detect that. It can detect, okay, I'm not going to get any more requests. I just have to finish writing and then finish closing the socket. Shut it down from my side. Now, nobody actually uses that. I shouldn't say nobody, but I think most people don't use that, and it would be uncommon to use it. And the reason for that is error handling. So bear in mind how TCP buffers work with error handling. So if I write some block of data, some bytes, into my outgoing stream, that write completes when it hits my local OS outgoing buffer, the send buff, SND buff. That send buffer holds my outgoing bytes, and my write is complete. I don't have a way to detect exceptions anymore and any kind of socket error because that write is complete. Until I do the next operation on my socket, I don't have a way to detect any socket errors. Now, the OS will transfer my send buffer into the remote machine's receive buffer, okay? And that's underneath what we can see as far as API surface. We don't see any of that. Out of order, reordering, packets were lost, they're retransmitted, they're retried. All of that stuff we don't even see. We have no clue on. But so here's the problem. What happens if this machine goes away, right? I've done my write. It's in the local OS buffer, and then this other machine goes away. My write is already complete. I don't have any way of being notified of this error. TCP will detect an error. It'll keep retrying and eventually say, okay, this machine is not responding, or it's gone, or whatever. So I'm going to put my local socket into an error state. So it will actually detect that scenario, but there's no way for me as the application to detect it because my write already completed. So the way that I prefer to work around this is to always have a read going. And I talked about this the last day or the day before. So I always have a read going. You should just always be reading from the socket, and that way we can detect any errors that happen on the socket, even on our socket writes, like the write that already completed for us. If it actually isn't delivered, then we get that notification of that, hey, this never actually got delivered, socket exception, reported to our read because it happens socket-wide. Well, the problem is you can't do that if you shut down one of those streams. So so think of it from the perspective of the server. Okay, so the socket sends a request. I get the request. Okay, I'm going to create a response for this. A lot of protocols are request response. Ours is not yet, but it will be eventually. So, at least part of it. Anyway, the client sends this request to me, and I'm talking from the perspective of the server. And then the client also closes their outgoing socket. They're like, this is the only request I want to make on this socket. So my incoming stream is closed. I can detect that on the server side. Be like, all right, my stream is closed. Now I'm going to write out the response, and here's the problem. I can write out the response, and that write completes because it goes into the OS buffers. It hasn't gotten to the client yet. Something happens to the client where they fail. I can't actually detect whether my response is sent or not. There's no way for me as on the server side to be able to detect that scenario because I can't read from the socket anymore. That incoming stream is closed. So I lose that way. So normally I like to read from the incoming stream all the time. That's to get everything coming in, sure, and also to detect any errors on the socket. And I lose that capability when the incoming stream is closed. I can no longer detect errors on the socket, even on my socket writes, until I go to write something else. But if the incoming stream is closed and they only sent one request, I would never write anything else. So that's kind of the problem with the half-closed streams. It's possible to do it. Maybe. Well, you can say, well, the server doesn't care if it's not able to write the response, right? A lot of times that's true. like an HTTP server. You know, if the client connects and asks for something and then the client goes away, the server's like, oh well, I don't care. You know, I'll just handle the next request. That's fine. In some protocols or in some scenarios, you really want to know if any errors happen. So, you know, in the more general sense, I read all the time. Always have an ongoing read. Just always be reading, and don't use the half close thing. When you're ready to shut down your socket, shut it down both ways. So I'm going to go ahead and do this both ways. That was a long explanation for one option here, one parameter that I'm passing. But that's the idea behind that. I want to shut down this socket and then go ahead and close it. Now this should be a graceful close, hopefully. All right, let's give it a try. So I can connect, and if I disconnect, yay. Oh, right. Okay. Because yes, once we close it, we can't call shutdown again. So what's happening is this close is being called. We want to make this close safe to call multiple times. So let's fix that. All right. So really what we want to do, yeah, I want to keep it in this latch, right? We gotta move it into this latch, which means duplicating some code, but that's fine in this case. Not duplicating a lot. There. All right. And I could actually say, if we close it with an exception, then actually we don't want to gracefully close the socket. That's an idea. Maybe we do want that. Interesting. I will have to think about that. Or, you know what we can do? I know this may not look like good code, but I'm just going to wrap this thing right here in a. We're just going to try to shut it down and close it. All right. I can connect here, and I can disconnect, and now it says yes. I was disconnected. Now we're getting that graceful close. All right. So let's see. I'm going to call it today. This is day 6. What we've covered today is proper error handling, flowing that through. We now have a way to detect errors. Our client still isn't able to detect errors. Like if I kill this server here, the client doesn't detect any errors or even a disconnect because it's not actually reading any messages. I think that might be what we need to add next. But what we did today was proper error handling. You know, we're using the what's it called, task completion source here to kind of latch the first error and like use that as our exception. So we've got proper error handling in now. We also have proper closing with the shutdown, which I totally forgot to put in. It has been too long since I've written a TCP/IP application. With the proper shutdown and calling shutdown before we close to do a graceful disconnect. So we've got the proper closing. We've got proper error handling. I also talked a lot about closing and why half-closed sockets aren't really useful in the general sense. Yeah, in the general sense, I would not use them. So things we're still missing. We need for our client socket to be able to read and handle incoming chat messages. We need to update our server to keep a list of client connections. And there are some somewhat tricky parts with that. So on our server side, we can keep a list of client connections and kind of like broadcast the chat messages. And also keep alive messages. We still have not addressed keep alives. That maybe the next day or maybe the day after that. But keep alives are also definitely coming because as it is right now, our code is not actually, it's not what I would call correct yet. We're not actually to a minimum viable TCP/IP application yet until we add in those keep alives. So tune in next time. This has been day 6. Thanks for hanging out, and I will see you next time, Monday morning probably. Thanks for watching.